Hello, welcome. Today we are going to solve another problem about related rates. I'm sure you have seen problems about ladders, about shadows, about sand that form into conical pile. But this problem is a little different, and this problem will lead us to a completely set of problems that has a lot of application in engineering. So let's get started. Given a circle of radius 10 centered at the origin, point P is initially located at 0, 10 and is moving with constant angular velocity following the arc of the circle towards the point Q, 10, 0, which it reaches in 0.5 minutes. At time t seconds, the coordinate of P is xy. Find dx dt when x equals 5. So let's draw our x and y axis, and we have a circle of radius 10 centered at the origin. Now there is a point P located at 0, 10, and there is also another point Q located at 10, 0. Point P is going to move towards point Q by following the arc of the circle, and it reaches point Q in 0.5 minutes. Our problem is to find the value of dx dt when x equals 5. If you notice, this problem doesn't seem to give us any rate. Aside from the fact that it's asking us from dx dt, the only given is x is equals to 5. But the problem mentioned that as p moves to point Q, it maintains a constant angular velocity. It is because of this information that we should be able to come up with another rate that is related to dx dt. Let us connect first point P to the center of the circle. So we now have a radius PO, which is obviously a length of 10. Now, the radius OQ and radius OP form an angle, and I will call this angle as angle theta. And just before point P starts moving towards point Q, the value of this angle theta is pi over 2. Of course, the time is 0. Now, there is a time when P is located somewhere in the first quadrant. Obviously, the value of angle theta is smaller than pi over 2. When point P coincides with point Q, the value of angle theta is exactly 0 and the time is 0.5 minutes. And with the information that angle P maintains a constant angular velocity, we will now be able to find the rate of the angle theta. Remember, angle theta changes from a value of pi over 2 to a value of 0, and it happens in a span of 0.5 minutes. So to find the rate of theta, we are now going to say d theta over dt. We'll get the difference of pi over 2 minus 0 and divide that by 0 minus 0.5. So we now have pi over 2 divided by negative half. And finally, we have the rate of theta as negative pi. Now, the length from O to P is 10. Now, let us drop a perpendicular line from point P to the x-axis. And also, let us draw a horizontal line to make a right triangle. So the length of the vertical side of this right triangle is y, and the horizontal side is x. Now, if you're going to look at the relationship between the angle theta, the y, and x, as you can see, you can create a function in terms of tangent. So we can say tangent theta is equals to y over x. If we are going to multiply by x, the left side and the right side of this equation, then we will get y equals to x times the tangent theta. Now we can differentiate this equation in terms of t. So we can get dy dt at the left side. And on the right side, we can apply the product rule. However, it will involve dx dt and also it will involve d theta over dt. We have the value for d theta over dt. That's negative pi, and we are looking for dx dt. However, we don't have any information for dy dt. So let's try to get rid of y by expressing that in terms of x. Let's look at again our right triangle. As you can see, the hypotenuse is 10 and the vertical side is y, the horizontal side is x, and we can take advantage of the Pythagorean theorem. So we can say x squared plus y squared equals to 10 squared. Now we are going to solve for y in terms of x. So we have the square root of 100 minus x squared. We can substitute this equation or this expression. So we will now have square root of 100 minus x squared equals to x times the tangent of theta. Now using this equation, we can find the value of dx dt, and we will only have to use the value of d theta over dt. So let's go ahead differentiate, but before we do that, let's convert the radical into an exponent. So we now have the quantity 100 minus x squared raised to the exponent 1/2. And the right side is x times the tangent theta. So we have to be a little careful in differentiating. The left side involves the chain rule, while the right side involves the product rule. So here's the result after differentiating the left side of this equation as well as the right side. Now let's look at what we have. We are, of course, looking for dx dt. In order for us to find the value of dx dt, we must have the value of x. We are being given that x is equals to 5. We have also the value for the d theta over dt, but we don't have the value for secant squared theta, and we also don't have the value for tangent theta. So let's take a pause on this equation and let's look at again our illustration. The value of x is known to be 5. So using that value, we will be able to find the vertical side of this triangle, again using the Pythagorean theorem. So we have 100 minus 5 squared. That will give us a square root of 75, which will give us 5 square root of 3. So the vertical side of this triangle is 5 square root of 3. Now we will be able to find the value of cosine theta. Cosine is defined as adjacent side divided by the side hypotenuse. So we will say cosine theta equals to 5 over 10. And using that, we can get the value for secant, which is just the reciprocal of cosine. So secant theta is 10 divided by 5, which is obviously 2. Now we need secant square. So we are going to square the right side and the left side. So we have secant squared is equals to 4. Now we also need a value for tangent, and obviously the tangent is defined as the side opposite divided by the adjacent side. So for tangent of theta, we have 5 square root of 3 divided by 5, which we can simplify as square root of 3. So now we have the value for secant squared theta, which is 4, and we also have the value for tangent theta, which is square root of 3. All right, so here one more time is our equation. We know now that the value of x is 5, the value for secant squared is 4, the value for tangent theta is square root of 3, and the value, of course, for d theta dt is negative pi. We are now going to substitute all these values into our equation. All right, so now we are going to simplify. Of course, we have to square the 5, multiply the negative 2 times 5, and also at the right side, we have to multiply 5 times 4 times negative pi. So here's the result. So now we are going to simplify further. Notice that the exponent for 75 is negative half. I will convert that into a positive exponent. So I will rewrite that as 1 over 75 to an exponent of positive half. All right, so here it is. Now I'm going to simplify further. I'm going to change exponent half into a radical. So I will have a square root of 75. Now, obviously, square root of 75 can be simplified further as 5 square root of 3. Now, I will multiply 1/2 times 1 over 5 square root of 3, and I will also multiply that by negative 10. I can simplify negative 10 and positive 10 in the denominator, so I will only have negative 1 in the numerator and square root of 3 in the denominator. I'm now going to multiply the left side and the right side of this equation by negative square root of 3. I use negative because I want the left side to become positive. Obviously, I will do that also at the right side. So here's the result. So the right side now becomes a positive 20 square root of 3 times pi minus 3. I'm now going to add 3 dx dt to the left side and the right side of the equation. Again, I will add 3 dx dt to the left side, and obviously the right side will cancel out. So I will now have 4 dx dt equals to 20 square root of 3 times pi. So finally, to get the value for dx dt, I will divide by 4. So the final answer to the problem is 5 square root of 3 pi. Thank you.